joined Smart for Aviation in 2017. I started my career with a company called Air Tours back in 1996 and progressed through a number of different roles that are all there on the screen from 1996 to 2017 through a couple of airline mergers called My Travel Airways and then later Thomas Cook UK that unfortunately went out of business just over a year ago. And for the last 7 or 8 years that I was employed with Thomas Cook in the UK, I held positions of Efb Administrator and Flight Ops Manager. I also worked on a shift basis in the flight dispatch and flight map planning departments as well, and ops control, where I became a certified flight dispatcher too. Okay, so onto the agenda that we're going to talk about here. I mean, this PowerPoint that we're going to talk about, this presentation that we're going to go through, we'll be venturing back to the future throughout this particular agenda, because a lot of the past and of the EFB is actually still part of the present of the EFB world as well. There'll be a little bit of duplication, but only on 1 or 2 slides with what Jakob presented earlier, just around the descriptions and the classifications. So I'll not go into a great level of detail there, because you've heard it and seen it. But we'll also talk about some of the advantages and disadvantages. We'll go then through some of the mounting and engineering challenges, the costs that airlines have to ask themselves, and the different questions around the costs that airlines have to ask themselves when it comes to deciding on whether they want an EFB and what solution they would also want as well. And therefore, what then goes on to the decision-making process, the approvals, the risks and the contingencies with our regulators and our governing bodies. And then, you know, the turn of 2010 pretty much seeing the tablet world explode onto the market. So we'll talk a little bit more about that. And then, of course, the software market that I'm obviously heavily involved in now, how that affects people from a change management process, whether it be vendors having to provide change management training, whether it be pilots that have to go through change management, cabin crew, engineers, etc., etc. A little bit about security and testing. And also then trials, if a company has to put together an EFB approval, like I've done quite a few of those. And then, of course, how we satisfy the end users, because we need to sell it to them. We need to get their buy-in in order to change the ways that that people like Matthias fly commercially, whether they can actually use the products or whether they find it easy to use paper, which is obviously defeating the object. And then a little bit about the future, which we'll talk about with connectivity that our founder Dirk talked about in his opening remarks. So a little bit about EFB description. I'm not going to go into it in a great level of detail. You can read it all there on the screen. Jakob talked about it earlier this morning as well. But fundamentally, the Afb purpose is to perform tasks easily, more easily and more efficiently. It's to reduce and or remove paper, therefore save money on logistical costs and weight and fuel costs. It can host a multitude of applications like charts and briefing material and performance applications, weight and balance applications as well, of course. But it's got to be comfortable and it's got to be easy to use. There'll be a slide right at the end about, as part of the crew buy-in section, about how comfortable and now the EFB architecture has got to satisfy our end users of the product. You can see some pictures there on the screen of the old Class 1, Class 2 and Class 3 certifications of an EFB. Like Jakob said earlier, now these have been amalgamated into portable and installed equipment, with a Class 1 and a Class 2 as part of portable category, and the Class 3 is part of the installed. The classifications, again, this is the last bit of the duplication that Jakob had earlier on this morning. We've got Type A and we've got Type B. So there's a list of our products. The Type A applications are the non-safety related applications, which are used for document storage and retrieval. And in our product suite that Dirk showed earlier, we've got our documentation management application, which is your aircraft library, FCOMs, MEL manuals, operating manuals, etc., and then the electronic forms applications, so forms that would use for submitting journey logs or voyage reports, or submitting safety reports in case we talked about bird strikes earlier with Matthias. So they're the type A applications, and the type B applications are the more safety related applications. So we're talking about performance, we're talking about briefing packages, we're talking about operational flight plans, and that all comes under the mobile Afb product that Smart for Aviation have, the briefing for pilots, interactive weather and no time applications, as well as load, weight and balance applications, and performance applications too. So that covers sort of visually where S4 Aviation sit within the Efb application classifications. I don't know if any of you remember the old Eddie Grant hit from the early 80s.
Shaun, sorry, but you muted yourself. You're still on mute. Oh, okay. Now we get it back.
Is that better?
Yeah.
Yeah, hang on. I think somebody must have muted.
Now we can hear you.
Now you can hear me. Okay,
yeah.
Let me start again then, because, okay, I didn't touch anything, sorry. Let me get back to where I was. Can you still see my screen?
Yeah, we just literally missed you for 2 or 3 seconds. We heard the beginning.
Okay, no worries, that's fine. So the old Eddie Grant song from 1981, We're Gonna Rock Down to Electric Avenue. I don't know if any of you remember that. I didn't burst into song there. I don't know if you're expecting me to burst into song either. But basically, this is the early days of the EFB. Back in early 90s, the earliest forms of an EFB just came from individual pilots who actually just took the laptops to work with them. The personal laptops, and they used spreadsheets and word processing applications just to perform such functions like weight and balance and filling out operational forms. These were like the earliest forms of an EFB. FedEx, I think, deployed the broadest first EFB application from an airline perspective around about 1994. And then after that, a German airline in '96 called Airline used two laptops for performance applications, and other airlines like Southwest and JetBlue followed as well. An actual lady called Angela Mason patented the first EFB in 1999. She was the first female chief pilot at American Airlines. She retired in about in 2007. With about 31 years experience of service to American Airlines. And she called the first patented EFB an EKB, which was an electronic kit bag. In 2006, after that as well, an airline that I used to work for with the first airline to actually, that was My Travel, before the merger with Thomas Cook. They became the first airline to deploy a combined ETL EFB Class 1 using GPRS connection. So just going through through the ages, the advantages of early FBs, they want to remove paper and therefore to cut costs. But the early EFBs were very expensive, and they were generally sold by the manufacturers. They were quite inflexible, so you had to take the whole product. The integration through your processes of your IT systems within an airline were quite complex. The end user experience was a little bit clunky, so they weren't so very user friendly, and they created bottlenecks. What I mean by that is they were generally shared by engineers and pilots alike. So they shared, let's say, a Panasonic Toughbook on an ETL, where the pilot had to wait for an engineer to actually finish off doing what he or she was doing before they could get their hands on it. So they created bottlenecks in a pressurized situation before departure, where the crew wanted to get away on time. So we had to make sure that as we go through the world of EFBs, that we reduce those bottlenecks and streamline those workflows. So mounting, there's a number of different mounting devices and different ways of mounting an EFB that you can do now on the back of the classification changes. We've got installed, which is more expensive, and an engineering STC is required. The portable way of mounting is cheaper, but it has to be stored if it's handheld below 10,000 feet. If you're using an old class 1 device. Viewable storage, like you can see on the screen there, with suction cups, that can be used as well. That's a more cheaper way of mounting a device on board a flight deck, as long as it's not screwed or mounted and it's in accordance with the regulations, and the device itself is less than, I think, 1 kilogram in weight. Simulators need to reflect the aircraft. A lot of TRIs and TREs used to complain that there was a number of different operators that were sharing simulators and they weren't reflecting the aircraft, and therefore the training was more difficult. And also our safety reports. If you've got lots of wires that are on board and they're getting in the way, they're interfering with some of the flight controls, some of the devices actually may fall out during turbulence, etc., etc. They increase the air safety reporting as well. Engineering challenges. This is a tech instruction that I wrote back in 2015 for engineering. Engineers are similar to pilots. They follow a series of steps to fix problems. So in order to actually get them to maintain and understand an evolving world of EFBs as we go through the more rigid, inflexible, installed EFBs to a portable EFB, engineers have to be trained, and they have to be able to adapt and come up to the changing of the market. So your approvals have to be well written. They have to be well understood by the engineering audience. They have to be able to understand the commercial off-the-shelf product, and they have to be able to adapt to that. More training was required, so therefore change management was required from an engineering perspective, not just a pilot perspective. And airlines had to manage that change amongst their employees. It had to be documented. So this documentation that I wrote back in 2015 had to be approved and be part of the technical manuals. And also we had the problems of who does what. Pilots used to get on board and the EFB had not been started, so therefore the update process of the documentation had not been done. And at -30 to departure, sometimes not all the updates had actually gone through or been updated to the devices. Therefore meaning a phone call or communication with operations, whether they could delay or whether they could proceed without those changes. So this, even though this instruction was actually written, these steps here for an engineer to actually start up the aircraft and power up the EFB when the aircraft was powered up, in order to get all the updates through in the maximum allowable time, had to be done. And we had to be nurturing the engineers to actually be able to do this, so the aircraft would get away on time. Costs. These are some of the things that airlines ask themselves when they begin down the journey of accepting a business case for EFB approval. Subscription costs, what are software subscription costs, IT subscription costs that we have to, how much will it be and how long will it take? How many devices do we need? Is it aircraft fit? Is it pilot issue, or both for contingencies? What software do we use? How much data do we need to update? What hardware do we decide on? Do we need to power them? Do we have to be connected? Therefore, is there any bundle prices or costs around that as well? And do we have to consider any battery life as well in case there's any power issues? So all those questions need to be asked, as well as probably many more when an airline board decides on whether to actually go down the road of an EFB approval. And these are the decisions that they need to make. So who did they decide on? What hardware did they decide on? Therefore, how much is it going to cost? When am I going to get a return of investment? How long is it going to take? Is it going to take 1 year, 2 years, 3 years? Do I go down the portable route or the installed route? What are the different software providers? Who are they? How much is it going to cost? What are the timelines? Who are the different vendors? Do I pick one vendor? Do I pick a multitude of vendors? What approvals do I need? What training do I need? How long is all that going to take? So it's a difficult road. Lots of different questions that airlines need to ask themselves, and they need assistance from people like myself who have had experience in writing numerous approvals to help them along that journey. Our regulator friends, we need to satisfy our regulators. We need to work with our national regulators and our international regulators, whether it be EASA, whether it be the UK CAA, whether it be the FAA. We also actually have to comply with AMC 2025, which is the acceptable means of compliance to electronic flight bags, which is something that I read permanently when I was writing the Efb approvals. Different risk assessments, different mitigations about those risks, what the likelihood of those risks are, how severe they're going to be, how many faults we're going to have, if we can mitigate against those faults, etc., etc. So we've got to bear in mind before we actually go down the journey of deciding on which EFB we want, we also have to look at the approvals, the risks and the contingencies too. Tablets, around about 2010, pretty much hit the market in a big way. And then we had the usual face-off between Microsoft and Apple about the best one to use and the various scorecards that you can see on the images here. A lot of these points here on the left-hand side, you might agree with, you might not, but they all have to be considered. In 2011, when I was at Thomas Cook, we originally gave iPads to our pilots. And then by 2013, we removed those iPads and replaced them with Windows devices because we harmonized with Condor in Germany, who had Windows. So that's also a decision that airlines have got to take. How we can manage that expectation with the workforce. Tablets might be cheaper, but they're less robust. They can be broke easier. They can be dropped, especially if you're giving them, to a bunch of pilots or a bunch of engineers. Do they take them home? Do they dock them somewhere? Are they easier to update, or are they harder to update compared to an aircraft? What's the battery life on them? Are they easier or harder to maintain? How many shutdowns can happen mid-flight? How many restarts have to be performed? Do they get hot? So therefore, we've got to satisfy a lot of the different approval processes and contingencies that you need as part of an approval. How do they actually act in a bouncy cockpit environment where a pilot's trying to identify a target that they want to press, but the aircraft is going through turbulence and you keep missing that target? Are the power sources reliable enough to charge up the devices? Do any loose wires get in the way of any flight controls, leading to more safety reports, etc., etc.? Therefore, what do we select? And also, when do we select it? We've got an improving hardware market now. So do I pick an iPad Air? Do I pick an iPad Air 2? Do I pick an iPad Pro? Do I pick a Surface 3, a Surface 4, etc., etc.? So you've sometimes got to nail your flag to the mast and say, I'm just going with that, and then make the decision and update it over a 3 or a 5 year period. Also, do I buy them? Do I lease them? What insurance have I got on it? What warranty have I got on it? There's all sorts of different questions that airlines need to ask themselves when they're going through this journey and making that decision. The software, so this is where we come in at Smart for Aviation. We offer a one-size-fits-all model. But it is a saturated market. I'm sure lots of you know that there's lots of other operators or lots of other vendors that do actually provide similar levels of software. I believe we're up there with the best, so other people can obviously make that decision as well. But I believe that our Smart Mobile and Smart Load and our communication application on our EFB is up there with the best of them. But what airlines, what applications do they really want? Do they want an application that satisfies both pilots and cabin crew, or do they just want something that satisfies pilots? Do they want performance with that? Do they just want a briefing material? What price models are they going to have to pay for? Over what contract period? How flexible are the different software vendors? How can they interface and integrate with the different IT processes that they've already got? Do they provide approval assistance? Do they provide training? What support do they have? And how do their employees work within the industry? How much knowledge of the market have they got, and how much experience of their SMEs have got within the workforce? Change management. This is something that's very important that I've experienced. Generally, people don't like change, so we need to be able to adapt to new things, and we need to be able to work with people when bringing in change. You've got the old 80-20 rule, where 80% of people will embrace it, but 20% won't. We generally like shiny things, so we like the best things. We like things to work. We like things to look well, and therefore EFBs have to work. If they don't work, then we're defeating the object, and therefore it could be easy to use paper, which is what we don't want. We have to streamline workflows, so workflows between flight crew and cabin crew, and engineering and other ground staff, to remove the bottlenecks. And also, the best hardware might be the best EFB. When we were evaluating things back in 2010, the back end of a Windows device was far better than an Apple device. So what might be good for front end, so good for a user experience, might not be good from an EFB back end IT perspective. And therefore, how much training do we need to give? Do we have to pay for that training? Do we have to bring every pilot in for classroom training? Can it be distance training? How's it going to sit on the approval, et cetera, et cetera? So there's lots to take into effect from a change management perspective. Security. We've all had lots of reports of people, in the back of the aircraft on seat 16D, trying to hack into the aircraft systems. Lots of reports of planes being grounded due to cyber attacks and things like that. The three most open areas are software updates to an aircraft, the various communication channels, and updating the EFB. And where we can help from a Smart for Aviation perspective is we can offer professional services and IT security as part of our professional services package, as well as the software that we actually have on the market in this area. Testing. This forms part of an EFB approval. I think the EFB approval that I wrote, the last one that I did back in 2015, was about 200 pages long. Only the first 50 pages were probably the most relevant. The last 150 pages had all sorts of correspondence and appendixes around testing and risk matrices and contingencies, etc., etc. But yeah, you've got to make sure that everything is tested properly against DMI. All your PEDs have to have the compliance tested against them, and then if it's a transmitting PED, you have to have a extra compliance as well. You've got to do UL 1642 lithium battery tests. We have to do environmental testing for rapid depressurization. And of course, you've got to be able to satisfy all the regulations around performance, weight and balance applications, and airport moving map display testing, which is something I think Jakob touched on earlier from an AMM perspective. Trials. This is something that I was involved in when I worked in the airline industry. In order to get an approval through, it's best to actually set a trial over a period of time. So you want a group of super users, that's pilots and engineers, and the best time to actually do it, or the best trial to put it on is a detachment. So we had 3 757s operating on behalf of WestJet back in 2013, I think it was now, or 14, that operated flights from Vancouver and Calgary down to Honolulu and Maui, down in the Pacific Islands, where we had a group of pilots that were there for 4 months and a group of engineers that were down there for 4 months as well. So we had a group of people that could actually use this as a trial. So paper was still on board the aircraft, but the devices were fitted as viewable stowage, as well as backups with pilot issue as well. So there was lots of technology on board those aircraft, and that could be then used as a trial to test connectivity of course, in different places. We're in different parts of the world. We could test how the update process worked. We could test any system functions and produce implementation plans of how we're going to roll it out across the fleet. And then you could include trial processes and results of that, of what worked, what didn't work in like a traffic light process of a red, amber and green, and show this to your regulators in order to get the approval. So a very important part of an approval is a trial to actually demonstrate that it can be done, and where it doesn't work, what steps you're gonna actually have in place to make a red, an amber, and an amber a green. Towards the end now of this presentation, we've got the crew buy-in part. So this is part one. For Smart for Aviation, we have pilots that work for us. We have people that have worked in the aviation sector like myself for over 20 years. And we obviously want to make sure that the products that we've got and the products that we use and the products that we sell to our customers and provide to our customers actually work for those that particular business unit. So a pilot utopia is how a mobile device or their EFB works for them across multitude of flight phases. So whether it be when they're away from home, whether it be for reporting for duty and during the briefing, whether it be in the pre-flight phase, the in-flight phase and the post-flight phase. So we have people that put work packages together, including myself, to make sure that all our products satisfy all those aspects of a pilot's day or a cabin crew's day as well. And then my penultimate slide is we of course have got to make sure that the whole experience is comfortable. So we can talk about the main architecture of an EFB. We can talk about it being from a back-end perspective, what the main storage area is, where the hardware is, what debugging tools are, what the backup system is. But most importantly, the most important part really is the user interface, which is the toilet seat, and the application software, which is the toilet roll. So that's a very important part from a user experience. If those bits aren't comfortable, then you're not going to have a very exciting experience, and that's what we've got to make possible for our pilot colleagues in order to buy into the applications and the hardware that we're actually working with. And then finally, connectivity, which is the future. So about a year and a half ago now, we at Smart for Aviation, we recently had our application certified within MySat as part of the CAP program. And that's basically designed to certify application across their satellite networks. And we want to build this in the future in a connected aircraft environment with connected applications, with economic package bundles for our customers. So they only need to get updated what they want to update from an in-flight perspective. We keep the data costs down. We keep the download times at the maximum. So therefore, we've got to have some apps that do get updated over an in-flight connectivity device, or sorry, that connectivity Wi-Fi, and some of them don't need to be. And we also think that SmartCom can provide them with updates directly to the EFB. Like Dirk mentioned right at the very start, I think, you know, airlines pay something like $50 for some ground paperwork to be turned around. That can also be, you know, obviously that can be done using our SmartCom application to update the EFBs both on the ground and in flight. That's it. Thank you, guys. I don't know if you enjoyed that. I don't know if I'm in time. I don't think I'm too far out of time. But I'll happily open the floor up to any questions.
Sure. Thank you, Shaun, very much for this presentation. And actually, we have some questions from the audience, so let me read them to you. First one is, how can Smart for Aviation help airlines through their EFB project?
Well, collectively, we've got a lot of experience within helping airlines do that. But personally, I can help. I think I must have done I must have done nearly a dozen approvals with regards to different applications, whether it be performance and weight and balance, or whether it be EFB applications as a bundle. So the company has got a vast of knowledge across EFBs and approvals, both with Transport Canada, the FAA, EASA, the UKCAA. Some of our customers have actually recently gone through them. EasyJet's just gone through a recent approval process, or he's actually on the back end of an approval process now, where they've just brought in just over 7,000 EFBs to their cabin crew and pilots. So collectively we can help massively. Individually, I've got lots of experience in it.
All right, thank you. And another question, what would be the biggest change to airline operation centers once aircraft are fully connected airborne?
What would be the biggest change? Well, the biggest change would be the crew, the ops control people now, who previously would just be able to see certain messages through AirCars, which would be quite expensive. They would be able to see interactive messages now on the systems directly using, let's say, our SmartCom application. And that would be a web-based tool on the ground and a native iOS tool, for example, on the flight deck. So you would get two-way peer-to-peer messages between pilot in command or flight crew and ground dispatcher or ops control staff. And you could also send direct alerts to them to provide them better situational awareness in flight. So it'd be massive change, rather than the more archaic and expensive sort of telex service that's only available to them now in a non-graphic form. So we could actually send things to them in pictures as well, and charts, etc., etc. So that would be a huge change.
All right, let's see if we have any other questions. I have received one. How long does an average EFB approval take?
Anywhere in between 1 year and 5 years, depending on a number of factors, depending on if you're getting a new aircraft with the kit already installed, or whether you're actually trying to retrofit your legacy fleet. So it can be anywhere, like I say, in between 1 year and 5 years. It also depends on if you have got any detachments in place and what your trial processes are, what your backup processes are. But yeah, it can be a very quick process, or it can be a very long process. And it also involves the relationship you've got with your regulator as well. If you work very closely right at the start with your regulator, then you're not actually waiting very long for them to actually approve what you've submitted to them. And you've also walked and gone through with them how the approval should look. So it's easy for the regulator to actually see and understand what your approval is.